certain properties, insulators have certain properties. Now, there are some materials, you will see that some of the properties match with conductors, some of the properties match with insulators. Who has entered?
Ma'am, is ray optics completely over?
Yes.
No, ray optics is not over. Ray optics we'll complete it tomorrow. Telescope was left. I think compound microscope was also left. No, compound microscope was also not completed. And prism, these three topics are left that we'll complete it tomorrow. Ray optics is not over. It's just that these topics, no, atoms, nuclei, semiconductors, these are coming in most of the exams. That's why I'm doing it first. On Sunday, I'll not start with wave optics. I'll complete atoms and nuclei, because now in your syllabus, no, atoms and nuclei, these are very, very small lessons. So we'll try to complete them by this week, at least modern physics, and this gets over by this week, so that you people are ready with your exam. Wave optics is a little lengthy in comparison to these short lessons, semiconductors, atoms, nuclei. So we'll try to cover wave optics in the last now, because the ray optics is a major lesson which is over. So we'll be only left with wave optics. Let us try to complete semiconductors, atom, nuclei this week. All right, by the next Saturday, when we start with the class, at least we should be able to complete with these lessons. Whatever is not completed on Sunday, yes, Sunday I'll start. No, so today is Friday, extra class. Saturday or normal class, we'll complete ray optics. Then we'll start with straight away atoms and nuclei. Then dual nature will be left, semiconductors, whichever portion is there. So we'll try to complete that by this week, at least before 9th of December. You have these small lessons completed, so that till mid of December or towards 20th December, your entire syllabus is completed, because we have to start with the revision classes also. And most importantly, all of you are having your exams. I've been receiving the syllabus, and in your syllabus, most of you are having semiconductors, atom, nuclei as your syllabus. That's why. Okay, Fia?
Yes, ma'am.
Okay. So yes, so semiconductors are solids which have the property, some properties match with conductors, some properties match with insulator, and some values of certain properties lie in between insulators and conductors. So instead, there was a lot of confusion in earlier time, whether you classify one material as conductor or you classify one material as insulator, because these materials, no, which were isolated, like silicon, germanium, these materials, there was a lot of confusion regarding their properties. So instead, what was developed by scientists? A final, a separate term was calculated by the scientists, which was semiconductor. So basically, semiconductor means that the properties are lying in between the solids, that is insulators and your conductors. So this only you should be aware of. Rest of the things are just as similar to, see, conductors and insulators you already know, right? Conductors and insulators you people are already aware of. What you're not aware of? Semiconductors, because semiconductors have their different properties. So certain properties, certain values we'll see. Like if you see the values for conductors have their resistivity ranges, they have their density ranges. We have studied about copper, we've studied about these properties we have seen. So here when we talk about semiconductors, some properties will be matching conductors, some properties will be matching insulator. Okay, so first let me start with these. Conductors have low resistivity. Insulators have high resistivity. 10 to the power are given also, but no need to remember. That is of no use. You never have to mention anywhere else. In fact, this table is also not very helpful from your examination perspective. All right. But low, high, remember, which has the lowest one, which has the highest one, this you should remember. So low resistivity is portrayed by conductors, high resistivity by insulators. And in between high and low, you have semiconductors. Easy? This lesson is not difficult. Logic gates were there initially. which had a lot of um, not even calculation part, you cannot say, but practice was required. So that is also deleted from your syllabus. Main thing, transistors are not there in your syllabus. Transistor had a lot of calculation from your current electricity. Now basic theory, PN junction and all. Let's see this. I'll give you break also. Today is a lengthy class, a little lengthy class, not just 1 hour class, 1 hour extra class, because test also has been cancelled. I think I informed Shahid also on the class that we were having JE class, and other students. You were supposed to have a test. So test was also cancelled for this weekend because of the classes only. So let us try to complete maximum portion that we are able to complete. And also other students also, please keep on updating me about your exams. Shahid, you are also having your exam, no? Shahid.
Yes, ma'am.
Shahid's I know, Rajita's I know. Other students, please, whichever date sheet you get, no, whenever for physics, when your main exam is starting and when is your final exam. Because I have to prepare you before your main exam. Once the exam start, you will not be able to study just physics. You have other subjects also. So that's why it's better either you share the date sheet, because many of you have done what? You are informing just 2 days before your exams. In that case, your syllabus does not get completed, right? So the best thing is that either share the date sheet with me prior to your exams, like Shahid has informed, Rajita has also informed. So by that, accordingly, only I'll arrange for the syllabus. Okay, so if you know the syllabus, if you know when is your physics exam, be it your pre-boards exam, whichever exams, unit test you're having, just inform me either in the chat column, WhatsApp, you already are connected. Okay, so high conductivity, resistivity, and conductivity are exactly opposite to each other. So high conductivity by conductors, low conductivity by insulators. And in between them, you have semiconductors. All right. Just one thing, industrial use of semiconductors are a lot, more than conductors and more than insulators. Reason is that they have a very good ability to control current. As I was mentioning you about transistors, transistors were devices where you could control the current different using NPN junctions. PN junction we'll see, so you'll be able to connect more. So they have the ability to control current. When you will perform calculations, you will also notice there that they have the ability to control current. That's why industrial use is more. When you see the industrial use is more, but conductors also exist, insulators also exist. All right. So then you have band theories, but write this down first. And by the time you people will be writing, I'll share a PDF with you that for semiconductors, it's not there. Semiconductors, please write down the class notes itself. For dual nature, for atoms, for nuclei, I'll share handwritten notes with you on WhatsApp. It's just that class one thing, they have no extra syllabus. These notes were not made after your COVID time. These were before the COVID time where the syllabus was lengthy. So it has topics which are not part of your syllabus now, like radioactivity. This has been deleted. Some portions of nuclei, some portions of atom, those will be extra. So that I'll tell you in the class itself, which you do not have to study. So don't start mugging up the notes itself. But every definition is already written in the notes. That's why I was saying we'll be able to complete all the 3 lessons by this week only, because notes are already there. You don't have to waste your time in the class by writing the notes. For semiconductors, I don't have any notes. You people have to write it there in the class. So start writing this. Okay, next topic. I hope you've written this. We have a concept of band theory. This was classification of solids. Again, we are classifying solids only. Insulators, semiconductors, conductors. This classification which we did right now, that was on the ability of the, or basically on the, upon the properties, right? You have a special theory which is known as the energy bands theory. So two bands are there which you have to understand. One is known as the valence band, one is known as the conduction band. This is a hypothetical concept to understand how the electrons are moving. Okay, see, what is conduction band? Basic definitions are there. I'll just read it out and I'll explain. Mainly through the diagram only you will understand. So conduction band and valence band, bands are closely spaced energy levels. Closely spaced energy levels. Energy levels we see in atoms also. So basically energy levels are present, which just show how, see, when we study atoms, you will study, all of you have studied already structure of atom in class 11th in your chemistry. So you must be having an idea about this because that is similar. What we'll be studying, no, this the next week regarding your atoms, nuclei and dual nature. That is exactly what you all have studied in your structure of atom class 11th chemistry. Yes, that lesson is in, I think, 11th only, no? Or 12th. I think it's in 11th. So that lesson, quantum physics, is exactly the same. So we'll see different energy levels are present. Those are basically orbits in which electrons are revolving. And electrons jump and energy is emitted and everything. The same concept. So like this, you have closely spaced energy levels in the system. Those are known as bands. So where the electrons are bonded either by covalent bonds, different bonds you have studied in your chemistry. So mainly by covalent bonds, the electrons are bonded. Those electrons are present in the valence band. We call that group as the valence band. Then once a certain energy is crossed by them, the bond is broken, the free electrons move in the conduction band and then contribute to the current. Conductivity, conduction, current which is flowing. This is because of the electrons, which we have already studied in current electricity. When we were studying the concept of drift velocity, we had seen that diagram, if you remember, how electrons are drifting towards the terminals of the battery. So those were individual electrons. So basically, what happens is, now understand, you'll be able to understand this. You have a concept of valence band. All right. In valence band, this is valence band. You have electrons which are present. These are bonded electrons. Electrons are here present. All these electrons are bonded electrons. All right. This is known as the valence band. How is the valence band constructed? All these layers of energy like this. First energy level, second energy level, third, all these are stacked up to each other like this. So this last one will be highest energy level of the valence band, right? This is the highest one. 1, 2, 3, 4, like this. They're stacked.
Ma'am, but how can electron and electron bond together? It will just repel, right?
What?
How can electrons bond
How are
together? It will
covalent bonds?
repel, right?
Electron do not form bonds. How are crystals formed? How are crystals formed? Electrons form the bond. Bonds are formed between electrons. Okay.
Okay, ma'am.
Crystal lattice also, there is one lesson of solids, I think, in your chemistry. There you must have studied. Okay, in chemistry, whenever you have studied, suppose silicon, have you not studied this concept? Like this we draw, then a single atom is left, odd electron species like this. So don't you draw the bond between two electrons? Understanding?
Yes, ma'am. Yes, ma'am.
Okay. So the same thing.
Understood.
So I was saying, yeah, so energy levels are present. So this will be the highest level. Highest energy level of valence band. Okay. Then this is known as the conduction band. There is energy gap between these two. You can see there is an energy gap which exists. This energy gap can be any value for different materials. These values are specified. Like silicon, one value is there. For germanium, one value. For different materials, different values are there. Some amount of joules of energy, because it is energy, so SI unit will be joules. So some energy is always present between valence bond and conduction band. When this energy gap is crossed, whenever the critical energy gap is crossed, so what happens? This bond, these bonded electrons which were present in the valence band, now they become the free electrons. See, if these electrons are bonded to each other, they'll never perform any role in conduction. They'll never, everything is made up of electrons, protons, nuclei. You know this, right? Molecular level, if you see. But nothing is conducting electricity because these are not free electrons. But in the wires, when we switch on, why are we able to sense the current? The entire concept of current electricity. Because there are presence of free electrons. So free electrons are existing. All right, free electrons are present. So these free electrons further then contribute to current. And see, this is known as EC. Why EC? Because this is the first layer of conduction band. So conduction band's energy levels will increase like this. So this is what? This is the lowest energy level of conduction band. This is lowest energy level of conduction band. This one is the lowest, and for EV, this is the highest. So basically, this is the entire theory which you have to understand. Now, how will you differentiate between, depending upon these things only, these factors, conduction band, energy gap, valence band, we'll be classifying the materials. Right now, we haven't classified. This is the general case which is existing. Now we'll see on the basis of band theory. This is clear. Band theory, you want to ask anything? Clear to all of you? I hope it's clear. Other students also respond. 7 of you present, only 2 to 3 are responding. Okay, if you have any doubts in between, also you can interrupt. It's not that doubt session is closed regarding band theory. In between, you can interrupt. Now, this is actually easy. If you will understand, no, you just have to, this is not a tough calculation. You have lots and lots of lessons which have so difficult calculation. Even in your ray optics, there are so many presence of different difficult questions. This is easy. It's just that you have to understand the concept of it. All right. So starting with differences between conductors, insulators, and semiconductors. So I'll start with conductors. In conductors, remember the conduction band and the valence band. There is either there is a separation between the two, either there is a separation between the two, that is smaller energy gap is existing. All right, energy gap can be present, or there are two possibilities. There are two possibilities that conduction band and valence band are overlap to each other. Wait, just okay. Yes, I was saying in conductors, there is either partial energy gap between them, small energy gap is existing, or they are overlapping to each other. Fine. This is about the energy gap. What about the valence band? Valence band is completely filled with electrons. What about the conduction band? Partially filled. This you can see. This is partially filled. What about valence band? Completely filled. Completely filled. They are overlapping or they can have a separation. If you see any material having this structure, you will call it as a conductor. All right. Conduction band is partly filled, valence band is fully filled, energy. And both the scenes are there that either it can be completely separated or some distance can be there. Now coming to insulators, how will you identify whether insulators are present or not? Now for insulators, see, conduction band will be completely empty. Partial, if it is partially filled, it will be conductors. For insulators, conduction band will be completely empty. First point. Second point, what about the valence band? It will be completely filled with electrons. And what about the energy gap? Will there be an energy gap or not? Yes, there will be an energy gap present. And this energy gap has to be greater than 3 electron volts. Fine. For example, you have the example of diamond, whose this energy gap is 6 electron. So if I see diamond and if I see the value of energy gap, I'm seeing this is 6 electron volt. It means this is greater than 3 electron volts. So directly I'll classify it as insulators. Then conductors done, insulators done. What about semiconductors? So in semiconductors, two things are exactly the same. Conductors are completely different. You will be very easily able to identify conductors. Conduction band partly filled, definitely conductors. But in semiconductors and insulators, both conduction band is completely empty. Valence band is completely filled. These 2 points are same. Difference lies in the energy gap. Energy gap exists, but energy gap is less than 3 electron volt. You have the example of silicon. These two values you have to remember. That's why I have separately written this. These values are present in the text lines of your NCRT. So they can be asked in your board exams and they have been used in right now you don't have the numericals though, but you should remember these, silicon and germanium, at least these two. So for silicon, it's 1.1 electron volt. For germanium, it's 0.72 electron volt. And you will be able to remember this. This is given a lot. Everywhere you will find these two. But in your NCRT, especially in the in-text, it's mentioned within the text. So you have to be careful with these. Fine. So these are the types of substances. Note it down wherever you are having any doubt. Please get it clarified.
Ma'am, these are the subtopics of classification of solids.
Yes, subtopics. Not subtopics, these are the classification itself. One is on the basis of materials property, those which you have written. Now which you are writing, this is on the basis of band theory. Now we have included conductors, insulators in our discussion till now. Now after this, we'll be just talking about semiconductors. Conductors, insulators are over. Written? Now see, now we'll be just talking about semiconductors. So the types of semiconductors, you have two types of semiconductors. Intrinsic means the core basic semiconductors. If it is less than 3 what? 3 volt, 3 electron volt. This you're asking, it is less than 3 electron volts. These are semiconductors, not 3 volts. Electron volts. The 1 electron volt is 1.6 into 10 to the power. E, you remember? E, yes, when we started the lessons of electrostatics, that time I told you. 1.6 into 10 to the power minus 19. So whenever you see EV, that is electron volt. Volt you already know. Okay. So EV becomes the unit of energy also when you multiply it with it. Okay, so there are two types of
Ma'am, is this
semiconductors.
another classification of semiconductor, like on the basis
This
of
is the
valence
first
bond
classification of
properties then?
semiconductors. Before this, we didn't classify semiconductors. We were classifying materials into conductors,
Okay,
insulators, and
okay.
semiconductors. Now
Okay,
we are
ma'am. Okay.
what did I say? I just said no. Now we'll be talking only about semiconductors. So this is the classification of semiconductors. So intrinsic semiconductors are those semiconductors which have no impurities in between them. No crystal addition is there, no doping is done between them. Extrinsic semiconductors are impure semiconductors. All right. Impure semiconductors means if a material is suppose made up of silicon atom. So deliberately I have added aluminium in between it. So that made it impure. So those are intrinsic. Those also have two types, P type and N type, that we'll study. But before we study, you have to understand the concept of electrons and holes. See, you have electrons which are actual physical entity existing. All right. Real concept is concept of electrons. When electron is absent, suppose electron has moved to a particular spot. The spot which earlier had electron now is deficit of electron. So in semiconductors, instead of just saying deficiency of electron, we have given it a term as hole. So these act like positive ions. You have negative electrons already. Holes are positive entities. All right, suppose this electron is moving. Suppose this electron is there. This has moved. So I'll say here a hole has been created. All right, like this. So this concept you have to understand here, because we'll be using the terms like holes are moving, electrons are moving. So you should have it in your mind, holes are moving means the deficiency, wherever the deficiency or vacancy of electron has been created, that is increasing. So vacancy of electron is hole. We use or treat these holes as positively charged particles. We treat them like this. Now starting with the types of semiconductors. So firstly, we'll talk about intrinsic semiconductors. These are pure semiconductors. All right. Here, suppose electron is present. This electron breaks off. This electron becomes a free electron which is available and it contributes in conduction. This conducts electricity. This conducts electricity. All right, this electricity. All right, this conducts electricity. So here, if one electron is leaving, one hole is being created, right? Because that electron has left. A vacancy has been created. That is the hole. Agreed? One more electron has left. So one more hole has been created. So 2 electrons, 2 holes. All right, 2 electrons and 2 holes have been created. 3 holes have left. 3 electrons have left. So 3 holes have been created. So can you notice number of electrons is equal to number of holes. Number of electrons is equal to number of holes. Why this happens is basically, you must have studied kinetic theory in your last year 11th physics. When the temperature increases, the thermal energy increases. Let me write it also. When temperature increases, the thermal energy increases. So because of this, electrons may break. Because of this, electrons may break. So whichever was the covalent bond, this breaks. Covalent bonds break, free electrons have become available and they conduct electricity. They take part in conduction. This is the mechanism that acts. But you have to remember, nothing else has been added. If this is a crystal lattice of silicon, one more thing, what is meant by this drawing? Basically, we write, no, silicon, electron, this is silicon electron. Covalent bond between them, bond is created. Here, this is its electron, this is its electron. Instead of just joining the lines together straight away, this is shown like this. So this is one single bond, both are equal. Okay, this means this is single bond because one electron will make the bond. Clear? Like this. So see, certain values also you have to remember. Energy gap, I have already told you 1.1 into 1.1 electron volt, and for germanium. See, limitations of intrinsic conductors, that why was there a need for making extrinsic conductors? If you have a crystal lattice of silicon atom, which is performing conduction, which is conducting electricity, so why to deliberately add atoms, make the task complicated and construct extrinsic semiconductors? The reason is that energy gap is very large. So many a times energy gap is not crossed. So that's why you need to have a considerable energy gap. That's why there was an issue. Second, number of electrons and number of holes are same, but they are very small. The ratio is also given 10 to the power 6 meter cube. Okay, almost 10 to the power 6 meter cube. It means in 1 meter cube, there are 10 to the power 6 holes or electrons only. So that is a very small number in comparison to the number of electrons which are present. 10 to the power 6 is a comparatively small. So that's why there was a need for extrinsic semiconductors. I'll start with extrinsic. First, you write it till here.
Ma'am, if energy gap is large, means what is the impact of it?
Energy gap is large. See, suppose I give a very, it's like cutoff. If the cutoff is very high, it's difficult to achieve that target. If the cutoff is comparable, so average students also will be able to cross it, right? So similarly, if the energy gap is very large, they'll be contributing more towards insulators. Why insulators are not able to conduct electricity? Because in insulators, energy gap is very large. Most of the electrons are not able to meet that energy gap. The bond is not breaking. Electrons do not pass through insulators, and we get insulators in our system, like wood. In wood, electrons are also present. Then why is wood not being able to conduct? Because the bond is not broken. Free electrons are not available. In conductors, why this happens? Because you see, they are partially overlapped also. And the energy gap is also small. Okay, Fia? Clear?
Yes, ma'am.
Write it down. Then we'll see extrinsic part. Because in extrinsic, you have the concept of P type and N type. Okay, now the next topic, extrinsic semiconductors. So, before we start with N-type and P-type, you should know the concept of dopants. Dopants are basically the elements which are getting added into your system. In your entire crystal lattice, one atom is making it, but if other element is coming into your system, then we call it as a dopant. And this entire process is known as doping. See, suppose you have an atom. This is a crystal lattice. All right. And some other element of your system, they have been added into your system. Now your atom, which was just made up of one single material, now is having somewhere an impurity. That's why we are calling it as extrinsic semiconductors. So these elements which are getting added, we don't use the term elements, we use the term dopants. So dopants are added, and this entire process of adding the external element into your system is known as doping. Now, if the dopant element, simple elements of your periodic table, if you are adding the elements which have 5 vacant electrons in their vacant shell, phosphorus group, that family, then we call it as pentavalent dopants. If it's the boron family, boron, indium, aluminum, and all, which have 3 vacant electrons in their valence shell, you write no Al plus 3, like that only. You write phosphorus P5 minus because of the valence electrons. So if it's 5 pentavalent dopants, if it's trivalent, if it's 3, then they are known as trivalent dopants. Now, pentavalent, if you have done pentavalent doping, your system is made up of N-type. You call that semiconductor as N-type. If trivalent, then you call it as P-type. That's it. That's it, the entire concept. Now here, what happens in case of N-type semiconductors? See, silicon present everywhere. +4, +4, +4 vacancy with 4 electrons, all are bonded. In between, I have added 1 phosphorus. So all the 4 electrons, phosphorus has 5, pentavalent doping has been done. So 4 elements will club with all those silicon, but 1 extra electron will be left. This electron, which will be weakly bonded electron. If you look at this electron, this is weakly bonded electron. All right, like I'll tell you one thing, energy is 0.045 electron volt. If I talk about the energy, this is 0.05 volt. That energy, thermal energy, which I was mentioning earlier. When the temperature increases, thermal energy rises, so free electrons become available. Now see, here what is happening because of this? Number of electrons in this case will be more than number of holes, because when these holes which have been clubbed together, if they will move, you will get a hole in your system, but you are having extra electrons. Number of phosphorus atoms getting added, more the number of phosphorus atoms getting added, more the number of electrons available, because these individual electrons will be creating their number. So that's why here you have number of electrons greater than number of holes. All right, this is the concept. And just the opposite concept, this I'll tell you. Just the opposite concept is present in P-type. In P-type, 3 vacant electrons, 1 is added. So what is happening? Silicon everywhere with +4, aluminium with 3. So 3 will be bonded and 1 vacancy will be left. 3 will be bonded, 1 vacancy is left. So it is creating a hole. Naturally, it's creating a hole. So number of holes are greater than number of electrons in this case. Okay. Now coming to the definitions and theory part of this. This I've told, impurities are added in ppm. ppm means parts per million, 10 to the power 6. Electrons are generated by 2 mechanisms: through the donor atom. Through donor atom means one directly by phosphorus atom that I told you, phosphorus atom is coming along with its associated extra electron. Second, thermally generated, which is exactly the same. That one electron will leave and one hole will be created. That we know. About those 4 electrons which are getting bonded with silicon. First one through donor atom means the extra electron, where you are getting no hole. You're not getting any hole because this is not moving in your system. Thermally generated one, which is exactly the same as that of intrinsic. Okay. So number density of electrons is much greater than that of holes. Then, yes, this I was telling. This is if you draw the same thing in conduction band, so it would look like, always remember, for N-type semiconductors, the energy gap or the energy threshold, the ionization energy, which you say, in chemistry we use this term. This is along near the conduction band. So for germanium, the value is 0.01 electron volt. For silicon, it's 0.045 electron. These are the energy gap values, not energy density, energy gap values for the N-type semiconductors. All right. So these two values you have to remember because they have also been. P-type, trivalent dopants, added in parts per million. Same thing here. Aluminium is acting as electron acceptor. So here we were using the term donor atom. Why? Because see, phosphorus with 1, 2, 3, 4 through thermal generated mechanism is contributing. But because of the presence of extra electron, this is donating. So we call it as donor atom. That's why the term donor atom is used, through donor atom where no hole is produced. Then second is thermally generated. Here aluminium has vacancy. It has a tendency to accept electron. You give it electron, it will form the bond. So we call them as the pentavalent atoms, the trivalent atoms as electron acceptor, electron accepting atoms. So same thing, hole is available here for conduction. Each atom of aluminium contributes for hole, so number of holes become greater. So here also holes are generated here by two mechanisms, directly through acceptor atom and thermally generated. This is about the number of holes and number of electrons, this value. And if you draw the same thing, the energy gap this time will lie near the valence band. And this value you don't have to remember anywhere else. All right. So conclusion, understand this well. This I'll tell you later. In case of N-type semiconductors, you have electrons, you have holes. Here, number of electrons in N-type is more because of presence of pentavalent atoms. All right. Number of electrons are more. So we call them electrons are in majority, while these are comparatively less. So we call holes present in minority. Clear? Because of presence of pentavalent atoms. Then you have P-type semiconductors. Electrons, hole, again the same concept. Here the number of electrons are less. All right, electrons are less. So we call electrons are present in minority atoms. Holes are present in majority, right? So we call them holes are the majority group. And why? This is because of presence of trivalent atom. All right. This is clear or not? The concept of the entire concept of N-type and P-type. Yes.
Yes, ma'am. Clear.
What about others? Except for Fia, nobody has understood. Any doubts? Deborah, what about you? You're understanding anything or not? Tarif? Shahid? Shahid, you've understood? Yes, Tarif? Okay, just one last thing. In case of intrinsic elements where no impurity was added. Number density was the same because number of electrons were equal to number of holes. All right, number of electrons were equal to number of holes. So here you have number density, number of electron, intrinsic, I'm taking it as same. But in case of extrinsic, you have two cases. So number of electrons are also different, number of holes are also different. So there is just one very simple, easy formula which connects all the three of them. Ne, NH, Ni. That is Ne, number density of electrons, multiplied to number density of holes is equal to square of number density of that intrinsic semiconductors. Easy. This you can just make it as a note point. First note point will be this. Second note point will be this. These are the concluding points for the entire discussion. So from here, start writing it down. Any doubts you have, please ask.
Ma'am, can you scroll up? Ma'am, can you explain this diagram again?
Yes, Pia, you were asking something?
Yes, ma'am, to explain this diagram again.
This is just the conduction band diagram, band theory diagram. It's just that the energy gap will lie somewhere near the conduction band. That's it. For,
Uh,
okay,
E is equal to 0.01
this is the
electron
value for
volt.
germanium. Ionization energy is value for germanium. Ionization energy means you are completely removing the electron from the atom. Okay.
Okay, ma'am.
Class over timings at 10. Yes, now just tell me one thing. What do you all want tomorrow? Because one more class I need for completion of semiconductors. So, do you want to complete semiconductors tomorrow or do you want to complete ray optics? Just text me in the chat column because I think this lesson will be over by tomorrow. Semiconductors only, no? Everyone is saying, okay, we'll complete this lesson. So, this gets over. Okay, okay, then semiconductors it is because this was the portion that took a lot of time, but this is over. This is over. We'll straight away start with PN junction. Okay, PN junction is a lengthy topic. It's not a very lengthy topic. It's just that this entire concept of PN junction we'll see from here. This I'll explain, this diagram. This we have already seen. Okay, class, you all can leave. It was a 2-hour class.